Hey everybody. So we're getting into 10.3 today, and we're going to be graphing our quadratic functions using what's called intercept form. All right, and basically, first things first, go ahead and get the title here and copy this slide, and then we'll dig into it. Okay, so intercept form is this form right here. Basically, the way to think about this form is it's the factored form of a quadratic function. All right. And you guys will see we're going to start out with them already being factored, and then eventually we will have to factor them ourselves. Though these will be the simple ones, they'll be really quick to factor. All right. But here's the big thing. When we get our quadratic function into intercept form, the first two things we're looking for are what we call our P and our Q value. Okay. And our P and Q value can be found with these numbers right here. Okay. Here's the big thing that you'll notice. Because these negative signs are part of the form, we need to take the number in front of the negative signs. So for example, if this said x minus 3, our p-value would be a 3, not a negative 3, a 3. All right. And then same idea, if it was a x plus 3, our p-value would actually be a negative 3. We'd have to think of this as a double negative. Okay, so the easiest way to just think about it is take the opposite of the numbers in these spots. If it's a negative 2, your p is a positive 2. If it's a positive 3, it's a negative 3. Okay? Okay, so what are those numbers? Those are actually the x-intercepts of our parabola. It's where they cross the x-axis. All right. From there, we can get our axis of symmetry using this really simple formula. The axis of symmetry is going to equal adding our p and q value and just dividing it by 2. Okay, remember the axis of symmetry is that dotted line that separates our parabola into two, equal halves. Okay, and then the last step will be finding our vertex, and it's the same way as before. The axis of symmetry gives us our x value, and then we need to plug that back into our formula and get our y value. Okay, cool. So we're going to do a few of these together. So stick with me, but hopefully we won't spend too long on each individual problem because they're pretty quick. Okay, so first things first, go ahead and get this above your first graph, and then we will try it out together. Okay, so first thing to recognize, this thing is already in intercept form. It's been factored and broken into, binomials. All right, so step number one is finding our P and Q value. All right, normally just, we say P is the one on the left, Q is on the right. It doesn't really matter which one you call which. Okay, but remember, we take the opposite of this number. If it's a negative 6, our P value is a positive 6, and our Q value is the opposite of this number, negative 4, positive 4. Okay, so there's our x-intercepts. So let's go ahead and plot those on our graph. It's where our graph is going to cross the x-axis. So it's going to cross right here at positive 4 on the x, and right here at positive 6 on the x. Okay, so there's step number one, pretty quick. Step number two is finding our axis of symmetry by using this easy formula, x equals p plus q divided by 2. All right, so step number two, so x equals, if you want to in your notes show yourself the formula really quick, so p plus q divided by 2. Okay, we can plug in our values here. P is a 6, q is a 4, divided by 2. Probably just do all this. 6 plus 4 is 10. 10 divided by 2 gives us 5. Okay, so our axis of symmetry is the line of x equals 5. If you guys remember, that's the line that goes through the x-axis at positive 5. Okay, so this is our axis of symmetry. All right, one thing to know, your axis of symmetry will always be equal distance between these 2 points. All right, sometimes this formula isn't necessary because if I would have noticed, oh, this is a 4 and this is 6, I knew my axis of symmetry was going to go directly between those two values. Okay, but when numbers get really far apart, say instead of 4 we had negative 4, it would have been harder to tell exactly where that thing was going to fall, and this is where the formula is kind of necessary. Okay, cool. So basically last thing is getting our vertex. Remember, we have half of it now. We know our x value. We just need to figure out our y value, and that's plugging that back into our equation. Okay, so I'm going to go ahead and rewrite it and leave spots for x. So y equals negative 3, We have an x minus 6 and an x minus 4, and our x value is 5. Okay, so obviously do the math in the parentheses first, and then you'll multiply all three numbers together. So we have a -3 times -1 times +1. So looks like we're getting what? +3 times 1, so we're getting y equals 3. And there is our vertex. So that means it's going to be, 5 on the x value up to +3 on the y value. Okay, and for these particular problems, that's all we need. We can go ahead and draw our parabola, which, by the way, try to draw your parabola all the way across your graph. There it is. Okay, a couple things to notice. I expected this parabola to be facing downward because we have a negative number leading our quadratic. Okay, if that was a +3, I would have expected this thing to be going up. Okay, cool. So I'm gonna have you guys try one of these in the already factored form. Okay, on your next graph, go ahead and copy this one, and start with step number 1. Figure out what your p and your q values are, and then step number 2, you can get your axis of symmetry using x equals p plus q divided by 2, and then step 3, you can plug that x value in. So go ahead and try this one out on your own. Okay, so first things first, my p-value, the opposite of this number is a +5. Opposite of this -3 is a +3. So it looks like my x-intercepts, where it's going to cross the x-axis, is right there at 3 and right there at 5. Okay, just by the way, I noticed that my axis of symmetry is going to go directly between these two dots. If I knew that and recognized it, I could probably just guess that my axis of symmetry is going to be a +4. Okay, but let's show in our notes that, yeah, if we plug in these numbers, 5 plus 3, and divide by 2, we get 8 divided by 2, which, yeah, is 4. Okay, so yeah, there's my axis of symmetry cutting down. And the question is, where does my vertex land? We know the x value is 4. We need to figure out the y value. Let's plug it back into our equation. So y equals -2 times x minus 5 times x minus 3, and our x value is a 4. Okay, so again, let's do this addition or subtraction in here. Looks like we got -2 times -1 times +1. Just so happens we got those numbers again. That doesn't always happen, just by the way. Okay, so -2 times -1 is 2. 2 times 1, 2. So there is our vertex, +4 on the x, +2 on the y, right? And it looks like when we draw our parabola, we're getting something that faces downward, which again, we would have noticed by noticing that, yeah, there was a -2 in the front there. Okay, so real quick, before we try some problems that require factoring first, let me just show you sort of a special case problem here. Go ahead and copy this on your next graph, and we'll see what's kind of interesting about this one. Okay, so yeah, let's try this out. Our P and our Q value are the opposite of these numbers. So opposite of -2 is 2, opposite of -2 is 2. Okay, so here's where it already kind of becomes interesting. My p-value, where my parabola crosses the x-axis, is at +2, and my q value is also at +2. All right, so same point. Okay, that's interesting. Let's move on to our next step. Okay, finding my axis of symmetry, I'm going to do p plus q divided by 2. Okay, 2 plus 2 is 4, divided by 2 gives me 2. So my axis of symmetry goes through at, well, let's finish this up real quick, at x equals +2. There's my axis of symmetry, which is, going through the x-axis at +2. All right, next thing, let's go ahead and plug in our values here and get our vertex. We know our x value is a 2. What's our y value going to be? Okay, well, let's plug it back into our equation real quick, see what happens. So we get y equals 3 times x, so 2 minus 2, and then x, 2 minus 2. All right, so these 2 minus 2s are turning into zeros, right? So we have 3 times 0 times 0. That's all just y equals 0. Okay, so my vertex is at positive 2 on the x, 0 on the y, that same exact point. So now the question is what do we do? We're out of steps. We don't know where our parabola is going. If this ever happens, basically what you need to do is check a point, and I always pick a point that's really near my line and plug it into your equation just like you would here, and then you'll be able to mirror the point. All right. So what I'm going to do is I'm going to check 0 just because, 0, it's close. I could check 1, I could check 3, whatever, but I'm going to check 0 because I think plugging in zeros is just easy math. Okay, so I'm going to go one more step on this thing. I'm going to rewrite this equation, y equals 3, but I'm going to plug in zeros for x. So 0 minus 2, 0 minus 2. Okay, so 3 equals 0 minus 2 is negative 2, 0 minus 2 is negative 2. So I'm getting negative 6. Maybe this turned into a big number here. Negative 6 times negative 2 gives me positive 12. So my point is when x is 0, y is positive 12, which would just be a couple ticks up here. All right, so 0 on the x, 12 on the y. There's another point. It's 2 units to the left. I can reflect it 2 units to the right. So here is my parabola. Right. So this is kind of a special case problem. You won't see this very often. Really, you'll only see this when your P and Q values are exactly the same number. Okay, if they're ever the same number, you'll know, okay, this is going to be one of those weird problems where you get that vertex immediately, you get your y-intercept immediately. These steps here, if we remembered, these are unnecessary. We would have known that, okay, it's going through the same point, my vertex is that point. You would just need to check a point near it, and then you'll be able to plot it. Okay, so let's now try a problem that has this with a normal quadratic function that is not in intercept form. Go ahead and copy this to you next to your next graph. Okay, so yeah, this thing, it's not in intercept form. I need it to. So I need to go ahead and factor this thing. This problem, all of these problems obviously want us to use intercept form. We could use a different way of graphing this, but we're doing, just intercept form today. So we need to factor this thing. Okay, well, if you guys remember, to factor this simple quadratic here, we just need to use the x method. All right, so this is going back to, I think the last chapter. You guys remember the x method, we put our c value up top, our b value on the bottom, two numbers that multiply to get the top, combine to get the bottom. Okay, so I'm thinking two numbers that multiply to get 15, I think 5 times 3. That does, but those combine to get a positive 8. I want them to combine to get a negative 8. So it looks like they both need to be negative. Okay, and really that is going to give me my factored form. Now I can write this as y equals, it's going to be an x minus 5 for one of my binomials, and an x minus 3 for my other. Okay, and I'm not going to give you problems that have you factoring really difficult quadratics. They're normally just going to require this simple x method. Okay, and from here, now we can go ahead and do our 3 steps. Okay, step number 1, finding our P and Q value. By the way, it just so happens a lot of these problems today have minus, negative numbers. They won't always be negative. You might have a positive 3 that turns into a negative 3. But for some reason, a lot of these problems today, they start with negative. So we take the opposite, becomes a positive 5, same thing, positive 3. All right, so yeah, let's plot our points. There is one of my x-intercepts. Here's my other. By the way, this is we saw these numbers already in another problem. I know that my axis of symmetry is going to cut through these 2 points. It's going to be exactly in between them. I know that x is going to equal 4. So I'm going to save myself a step and not do the equation and just go say, yeah, x equals 4. Okay, but just remember, we could use that formula if we really needed to. Okay, cool. So now we know our x value, it's 4. We just need to figure out our y value. Let's plug it back into, I'm going to plug it back into, actually, you can plug it back into either one of them. So yeah, instead of actually the original, let's plug it back into this. I think it's easier just to subtract the numbers. Okay, so I'm going to use this thing here because they're the same. So y equals x minus 5, our x value is 4. So 4 minus 5 and 4 minus 3. Okay, just so happens we're getting a negative 1 and a positive 1. Doesn't always happen, but it sure is happening a lot today. Okay, negative 1 times positive 1 is a negative 1. Okay, so there's my vertex at positive 4 on the x, negative 1 on the y, and I can draw my parabola. Okay, one thing I want to point out, say we wanted a really detailed parabola. I could plug in other numbers. I could plug in a 2 for x, and I would probably get maybe like a 2 for y or a 3 for y. I could plug in as many points as I liked if I wanted a really detailed parabola, but this is enough to get the general, shape of it. Okay, so let's see. I'm going to skip this one. I'm going to have you guys go ahead and do this one on your own here. Go ahead and factor this using the x method. And then from there, you can try the 3 steps and get this thing on the graph. Okay, so go ahead and try this one out. All right, so my x value is a 12, my y value, or sorry, my x value, my c value is a 12, my b value is a negative 8. Two numbers that multiply to get 12 and combine to get negative 8. I'm thinking 6 times 2, but they would both need to be negative, right? So it looks like those are the numbers that work. So now we've got our factored form of our quadratic x minus 6 times x minus 2. Cool. So now let's get our p and our q values, the opposite of these numbers. Again, they're negative. It just so happens they might sometimes be positive, but these are negative again. So taking the opposite, positive 6, positive 2. Okay. So let's go ahead and plot them. Looks like positive 2 and positive 6. Okay, I'm looking at these and I'm thinking right in the middle, it looks like my axis of symmetry is going to be a positive 4. Okay, but just to make sure, let's plug them in this time because I don't want you to always just kind of eyeball it. But yeah, using my little formula, p plus q divided by 2, yeah, 8 divided by 2 gives me a 4. All right, sorry, I'm getting a little sloppy here. But yeah, it looks like x equals 4. Okay, so there's my axis of symmetry going through a positive 4. Last thing, where does my vertex land? Okay, so I have my x value, it's 4. What's my y value? Let's figure it out by plugging in. Again, I'm going to plug it back into this one. You can plug it back into either one of these, you get the same answer. Okay, so let's see, y equals 4 minus 6 times 4 minus 2. Okay, 4 minus 6 is negative 2. 4 minus 2 is positive 2. Negative 2 times 2 is negative 4. So negative 4 for y. So positive 4 on the x, negative 4 on the y. There is my parabola. I always get all messy on this, but I'm trying my best to make it look nice and smooth. There, that looks good. Okay, so yeah, that's graphing using intercept form. Not too bad. Sometimes in some cases it's faster than using standard form that we saw in the last couple sections. Okay, but yeah, I'll see you guys in class. Bye.